Welcome to Project Aerospace. Today, we are going into the world of an aircraft named after a whale and born from a pressing need that everyone else ignored. This aircraft looked like a whale that wandered onto a runway, but do not let that fool you. Inside, it moves massive wings, fuselages, and other aircraft components across Europe with astonishing efficiency, and it does so with grace that makes its enormous size almost unbelievable. While other cargo planes struggle with oversized loads, this plane has turned transporting huge aircraft parts into almost routine work. Cranes lift entire fuselages into its very large belly. Crews secure them for flight, and pilots guide this giant through the skies with precision that belies its bulk. People stop to stare at on runways, take photos for social media, and call it the smiling whale of the skies. But inside it, it's serious business. This is a plane that does what no ordinary cargo aircraft can do. And it has changed not just the way modern cargo business is done, but what is thought to be possible. It carries a solution to a problem most people didn't even know existed. This is the story of the Airbus A300-600 ST Beluga, the logistical powerhouse that no other aircraft could match for decades. Modern airplanes are built from enormous parts that are produced in multiple locations across Europe. Wings may be manufactured in one country, fuselages in another, and tail sections somewhere else entirely. Transporting those components to the final assembly line poses a serious challenge. Standard cargo planes were far too small, and moving oversized parts by road or sea was slow, expensive, and prone to delays. Other manufacturers had not fully solved this problem. Some relied on trucks or trains, which could only handle sections within certain size limits and required multiple transfers. Shipping by sea was possible, but the journey could take weeks and schedules were unreliable. There were no purpose-built solutions for the air transport of extremely large components. In the 1960s and the 1970s, planes like the Boeing Super Guppy offered a partial solution. The Super Guppy could carry oversized cargo, including aircraft sections, but its payload was limited. It was slow, and the loading process was cumbersome. Production lines still faced bottlenecks, and delays were common. No other manufacturer had developed a modern, dedicated cargo aircraft capable of handling today's ever-larger airplane components efficiently. The solution came with the design of a purpose-built transport aircraft. The Airbus A300-600 ST Beluga was created to carry enormous components in a single flight, eliminating the need for multiple transfers and complex logistics. Its cavernous cargo hold, rounded fuselage, and hinged nose door allow it to lift entire fuselages, wings, and tail sections with ease. With this aircraft, what once took days of careful coordination, multiple flights, or slow transports by road and sea can now be completed in a single, efficient mission. While its main role is moving airplane parts, the Beluga has occasionally carried other oversized industrial components, satellites, and unusual cargo that would not fit on any standard cargo plane. The aircraft solved a problem that had frustrated manufacturers for decades and became a flying backbone for modern aircraft assembly. The Beluga is based on the A300-600, a regular passenger jet stretched and modified into something extraordinary. Imagine taking a plane that was already reliable for long-distance flights and then widening and raising its body until it could swallow an entire car, or, in this case, other aeroplanes. The bulbous fuselage, the raised floor, and the massive cargo doors all start to make sense once you understand the plane's job. Its dimensions are jaw-dropping. The plane stretches over 56 meters from nose to tail, nearly the length of 6 London buses parked bumper to bumper. The wingspan reaches almost 45 meters, and the height exceeds 17 meters, taller than a 5-story building. Inside, the cargo hold is over 7 meters high, 7 meters wide, and almost 38 meters long. To put that into perspective, a standard 2-story house could fit inside with room to spare. This enormous space allows the Beluga to carry full fuselages, wings, and tail sections of aeroplanes without disassembling them. The Beluga can lift up to 47 tons, which is roughly the weight of 7 adult elephants. It cruises at speeds around 864 kilometers per hour, faster than most people drive on a motorway, and can cover 1,650 kilometers without refueling. This means it can take enormous airplane parts from one factory to another across Europe in just a couple of hours, saving days of transport compared to older methods. Before the Beluga, transporting these oversized components was a logistical headache. Standard cargo planes, such as the Boeing 747 freighter, could not carry full wings or fuselages. Engineers had to break them down into smaller pieces and reassemble them at the destination. Some other manufacturers tried using modified planes, like the Boeing Super Guppy, but those were slower, less efficient, and often needed multiple trips for what the Beluga can do in one flight. This plane solved a problem that no other transport aircraft could tackle reliably, moving massive, awkwardly shaped airplane parts safely, quickly, and in one go. The Beluga's capabilities are impressive, but what does it actually mean to a normal person? Think of it this way. Building a modern airline is like assembling a giant Lego set spread across several countries. Without a plane like the Beluga, pieces would arrive late or in pieces too small to be useful. The Beluga makes sure the right parts get to the right factory on time, keeping the assembly line running smoothly and airplanes flying off on schedule. It may sound like a technical problem, but in practice, it means faster production, fewer delays, and better efficiency across the entire aerospace industry. Step inside the Beluga, and the scale is immediately striking. The cargo hold is enormous, stretching almost 38 meters from nose to tail, with over 7 meters of height and width. Imagine a two-story house turned on its side and then extended even further. That is the space available for cargo. It's not just big. It is carefully designed for oversized airplane parts that cannot fit into any standard freighter. The Beluga can carry entire fuselages, complete wings, tail assemblies, and other large aircraft components without taking them apart. For perspective, a single A320 wing fits comfortably inside, and the cargo hold can even handle fuselage sections from wide-body aircraft like the A350. Each load requires meticulous planning to make sure it fits perfectly. But once it's inside, the plane transforms into a smooth flying conveyor belt, moving parts across Europe with astonishing efficiency. Every load is secured using a combination of hydraulic locks, straps, and platforms designed to keep the components perfectly stable during flight. The plane's low and wide floor allows cranes to slide fuselage and wings directly into place, reducing handling time and the risk of damage. This careful design is why the Beluga can safely transport components that would be almost impossible to move by road or rail. The cargo hold also has a gentle curve to its ceiling, giving extra clearance for taller pieces, and the widened fuselage ensures that there is room to maneuver large items without scraping the walls. This space is more than just an empty box. It is a purpose-built environment designed to move the building blocks of modern aircraft from factory to assembly line quickly and reliably. What does this all mean in practical terms? Every flight keeps the complex network of factories and assembly lines running on schedule. Without the Beluga, components would have to be cut down to smaller sizes, shipped in multiple trips, and reassembled, slowing production and increasing costs. Instead, the aircraft carries entire pieces in one go, ensuring that assembly of an airliner can proceed without interruption. For the public, it may seem like just a giant plane, but in reality, it is a critical link that makes modern aviation possible. Before we look into the mechanics, take a moment to think about this. Have you ever seen a plane so big it carries other planes? Drop us a comment and tell us what you think about this massive flying transporter. Now let's see how it actually moves. The Beluga is not just a big plane, it is a precision machine. Loading begins with cranes carefully lifting fuselages or wings onto the hold floor. The cargo slides on hydraulic platforms, gliding smoothly into position. Once inside, each piece is secured with straps, locks, and supports designed to keep it rock steady, even when the plane bangs sharply or hits turbulence. The floor itself is engineered to make loading efficient. Its low height and wide span allows cranes to operate easily, and the slight curve in the ceiling gives just enough clearance for taller fuselage sections. This combination of design features means every load, no matter how awkwardly shaped, can fit safely without scratching the walls or shifting in flight. Flying a plane this size requires careful planning. Despite its bulging fuselage, the Beluga cruises at 864 kilometers per hour and can cover around 1,650 kilometers without stopping. Pilots rely on precision navigation and pre-planned flight paths to move from one factory to another efficiently, sometimes threading through busy European airspace with other commercial flights. Every takeoff, cruise, and landing is choreographed. Pilots, ground crew, and factory teams coordinate to make sure the cargo is ready, the load is balanced, and the flight can proceed without delays. Each mission may only last a few hours, but behind the scenes, it involves careful timing, teamwork, and engineering expertise. In short, the Beluga works because every part of it, from the wide floor to the hydraulic locks to the flight path planning, has been designed to turn what would have otherwise been a monumental logistical nightmare into a routine operation. It is big, it is powerful, and it moves with surprising elegance. But more than that, it keeps the aerospace supply chain running, ensuring that massive airplane components reach their destination safely and on time. When Airbus launched the Beluga in 1995, it created a new standard in transporting oversized aircraft parts. At that point, no other manufacturer had a plane capable of carrying full fuselages, wings, and tail assemblies in a single flight. Standard cargo planes simply could not handle the size and shape of modern airliner components. Boeing's comparable solution, the Dreamlifter, did not take to the skies until 2006 and entered service in 2007. This meant Airbus had already been flying a purpose-built, high-capacity transporter for over a decade before Boeing even launched its answer. During those years, the Beluga handled Europe's complex aerospace logistics efficiently, moving enormous components across multiple countries with unmatched speed and reliability. The Dreamlifter was developed specifically to transport Boeing 787 components from global suppliers. It could carry large fuselage sections and wings, but Airbus had already proven the concept with the Beluga. The Beluga's earlier launch and operational experience gave it an edge in refining loading procedures, flight planning, and ground operations. Even today, the Beluga XL continues to operate with efficiency that Boeing struggled to match for years. Its combination of speed, cargo capacity, and purpose-built design meant that Airbus dominated the niche of supersized airliner transport long before Boeing fielded a plane that could even come close. In short, while Boeing eventually built a capable plane, it could not match the Beluga's head start or the operational expertise Airbus accumulated in that time. While Boeing was still playing catch-up, Airbus consistently left it in the dust when it came to transporting oversized cargo. The original Beluga solved a problem that no other plane could handle, but engineers did not stop there. They kept refining the concept, making each new version bigger, more capable, and even more efficient. The first iteration, the A300-600 ST, became a workhorse for transporting aircraft components, but as production needs grew, Airbus realized it needed a plane with greater payload and range. Enter the Beluga XL, which first flew in July 2018 and entered service in 2020. It is based on the A330 platform, giving it a longer fuselage, a wider cargo hold, and the ability to carry up to 51 tons, but 4 tons more than the original. The Beluga XL also has longer range, covering over 4,000 kilometers without refueling, allowing it to move more components between factories more efficiently and reduce the number of trips needed. Its upgraded engines provided smoother flight and lower fuel consumption, making it not only bigger, but smarter and more economical to operate. Since its launch, the Beluga XL has been integrated into Airbus's production network seamlessly, flying hundreds of missions to transport wings, fuselages, and other large components across Europe. The success of this model shows how continuous improvements and engineering foresight can extend the life and capability of a concept that started with a single revolutionary idea. The evolution from the original Beluga to the Beluga XL highlights a simple truth. Solving a gigantic problem once is impressive, but refining it over decades is what cements an aircraft's legacy. The Beluga changed the way aircraft components are transported. Instead of relying on multiple trips or disassembling parts, it moves fuselages, wings, and tail sections from one factory to another in a single flight, keeping production lines on schedule and reducing costs. Its design and reliability mean manufacturers can plan assembly without worrying about moving oversized components. While the Boeing Dreamlifter followed a similar concept, Airbus had over a decade of experience operating the Beluga before Boeing introduced its solution. For most people, it looks like a smiling whale in the sky. For the aerospace industry, it is a practical and dependable tool. Every flight ensures larger components reach their destination safely and on time. The Airbus A300-600 ST Beluga and its larger Beluga XL successor show how targeted engineering can solve a specific challenge efficiently. It's a reliable workhorse that keeps aircraft production moving across Europe. That's the story of the Airbus Beluga, a plane designed to do what no ordinary cargo aircraft can. It moves massive aircraft parts safely, efficiently, and reliably, keeping production lines running and the skies busy with something truly unique. If you enjoyed learning about this remarkable transporter, make sure to like the video, drop a comment, and subscribe to Project Aerospace for more stories from the world of aviation. Don't forget to tell us what you think of the Beluga and its role in keeping modern aircraft flying.